Okay, now we're going to look at parallel circuits, and I've left our series circuits up on the top just so you can compare the circuits from the parallel to the series a little more easily. We don't have anything like a one bulb parallel. There's no such thing. One bulb or one resistor and one battery, connecting wires, simplest safe circuit, it's series, everything's all in one row, period. So the first thing we can compare is two bulbs in series to two bulbs in parallel, and the first thing you should notice is the bulbs glow more brightly than they did in series. Now let's just check. We had 9 volts across our battery here, and indeed we have 9 volts across our battery here, except I think I have my, I have my electrodes backwards. Remember that negative sign just means I'm reading it the wrong direction, so 9 volts across there. Now the interesting thing is when I read across the bulbs here, I end up with something very strange. Wait a minute. Let's see what I did with my connector here. There we go. 8.999 volts. Again, that's 9 volts. And then across here, I may have my electrodes too close, 8.9998 volts. Again, minimal resistance in the wires is demonstrated, but the resistance essentially through each, the potential through each bulb is the same as the potential across the battery, and up here it was not. Up here these were equal resistors, and so we saw that it sort of was half, right? Okay, so the point is, if I put my electrode here in the circuit, or here in the circuit, or here in the circuit, I'm not judging the difference in that particular circuit. Just like when I put my electrodes here and here, it was no different than any other two places in the circuit. So let's look at the current in that series parallel circuit. 1.8 amps coming out of the battery, and then in each branch I have half of that, only because I have equal resistors. If I change that, it'll change, but 0.9 here and 0.9 here, and indeed what I have going into the branches should add up to what I have coming out of the branches, and it does. Okay, so now I've added another bulb, and we notice that my current flow out of the battery has increased. I still have 9 volts. Again, it's backwards, but 9 volts across the battery. I have 9 volts across each resistor, each light bulb in this case. Remember, a light bulb is just an example of something that applies resistance. A resistor, a physical resistor, is just that coiled wire that we talked about. So again, the voltage across each bulb is the same. The current flow out of the battery is 2.70 amps. In the first branch it's 0.9, in the second branch it's 0.9, in the third branch it's 0.9. Interestingly enough, we saw 0.9 and 0.9 here, so we've actually increased our resistance by 0.9 amps. Now this is one of the things, more pathways for the current to flow, the less effective resistance we have in the circuit. Then we noticed when we put 3 batteries in that we ended up with a larger potential difference, had a higher current flow. We had 3 bulbs in parallel, we had lower resistance, so higher potential difference and lower resistance should give us much brighter, and indeed when I hook it up it does. So we'll see that I still have 27 across the batteries in this one, so there are my electrodes, and sure enough 26.998, again effectively 27. My potential across my bulbs is still 27, 26.99. Let me move the meter over a little closer so we're looking at it a little more easily. Again, 26.99 and 26.99. So we're good. All the way across all of these is essentially 27. And then the current in the coming out of the battery is 8.1 amps. 8.1 amps. We've increased that potential difference significantly. And so we should see these go up as well, 2.7, 2.7, and 2.7. And that should give me 8.1 coming back out. You can see considerably brighter than the other. Okay, that's the parallel circuit. The last thing that you should notice about this is what happens when I take something out. So when I take out anything, any part of this circuit, whether it be a bulb or a resistor, a bulb or a wire, it doesn't matter. I have a break in the circuit and current no longer flows. If I take out a wire in a branch, then this path is not complete, but I still have a path here, and that effectively works for the ones with multiple bulbs as well. However, if I take out a wire close to the battery pack, all of a sudden you'll notice the current stops because I no longer have a path to get through the circuit. As long as I have some connection, then I get current flowing through at least some of the bulbs, but if I don't have a connection to get me through to the first path, I have no current flow. And this is going to be an important thing as we start talking about safety devices. If I want to put a safety device in, for now let's just put a switch in here. Take that one out. Let me put a switch in here. And you'll notice that if I put a switch in here, now I can control, maybe if I can grab hold of it. I think I get the simulation to up there. There we go. There we go. Now I can control. I can close that or open that switch if it was working right to control the circuit flow. If that switch opens, and for now I'm just going to remove it, then I can close I can stop the flow of current in the circuit, and that's the important thing.